Okay, so we worked with absolute values and we worked with inequalities. We didn't quite put them together, and so I want to practice that real quick. Or even if we did put them together, it's not been since August. So it's been a hot minute. So what the heck can we do with this? What do we need to do?
Split it into two.
Splitting it into two options or setting it up kind of as a sandwich would work for these. Because what we have here is that this absolute value needs to be less than or equal to 5, which means it's either going to be less than 5 or bigger than negative 5. It needs to be between the two of them. So we're looking for this kind of interval. Remember that our absolute value is the distance from 0. So this little chunk needs to wind up somewhere between positive 5 and negative 5. So it's going to be on this number line up here between these two. I know, you're going to be grumpy. Too many dang layers. So when we're setting these up, when we have less than and is a good way to remember it, I need to be less than 5 and more than negative 5. So I'm going to set this up kind of as a sandwich. So I'm going to take my negative 5, which is going to be less than or equal to whatever's inside here, my negative 6 plus x, which is less than or equal to our positive 5. So that's how we can get it out of the absolute value. You can absolutely set that up as two separate inequalities if you want to. Just be careful that we make sure when we put it in our interval notation that it's either where it overlaps or two separate ways. What can I do to get my x by itself here? Add 6. So if I need to add 6 to this middle piece, I need to add 6 over here and over here. So we're going to wind up with 1 is less than or equal to x, which is less than or equal to 11. So the interval on which we have solutions here in interval notation is going to be what? The smallest it can be is 1. We put it with a bracket because it can equal it to 11. It's like you should have done these before, but it may have been since Algebra 1 the last time we did an absolute value inequality. But that's our interval on which we have a solution. So we isolate our absolute value, bless you, and then we can deal with our inequality. So what should we do over here? Add 5 first. Before I try and deal with inequalities, let's add that 5 and get our absolute value by itself. So we're going to add 5 to both sides of this inequality. That's going to give us that the absolute value of 7x minus 9 is greater than 23. So if we think about our number line, my number line's too short to do this. At 23, my absolute value needs to be bigger than 23. Or, what could it be? What's the other option we're going to have for our interval? Less than negative 23. If I take the absolute value of anything less than negative 23, it will also be true. So when we split this up, I need to have two inequalities because I have two different pieces here. So it could be that my 7x minus 9 is in fact less than, whoa, that's tiny. Hang on. I'll write that bigger. I zoomed in too far. 7x minus 9 might need to be less than negative 23. or my 7x minus 9 is going to be greater than 23. So we have two different inequality signs. The reason we didn't have that on the left-hand one, just so we have the picture up here, is we were looking at our positive 5 and our negative 5, and it was between. We were in between the positive 5 and the negative 5. So down here, our 7x minus 9 less than negative 23. What do we do on this one? Add 9. That's going to give me that 7x is less than negative 14. Negative sign didn't show up. Which means my x is less than what? Negative 2. Same kind of vibe on the right one. Add 9, so we're going to have our 7x is greater than 32, which means my x is greater than, does 32 divide nicely by 7? No. 32 sevenths. It's gross, but it's a thing. So my intervals on which we have our solutions are going to be what? How do I write that x has to be less than negative 2 as an interval? From negative infinity to negative 2. And we use a parenthesis because we're not equal to. How do I put this one as an interval? (32 sevenths) to infinity. And remember, Buzz Lightyear's wrong. You can't go past. How do I join them up? Union. We can't go beyond infinity. Buzz Lightyear is wrong. Great or. So greater, great or. That's kind of the easiest way to remember. Whenever you have your absolute value isolated, and we get, oh, that's not how we spell great. That's the wrong great. Great or. Less than. So you can do and. We can do it as one sandwich, less than. Great or would be or. So one other thing I want us to remember for our inequalities that we haven't practiced in a hot minute on this bottom left one, we've got a great or. So we're going to set this up as our two inequalities here. My absolute value is isolated. And I have very little space over here. That's okay. I'm going to build myself a little wall so I can use that space over there. So since we have a greater than, we're going to set this up as two inequalities where I'm going to have my x over minus 5 might exactly be greater than 2. Totally fine, might be the thing. Or my x over negative 5 might need to be less than negative 2. So those are my two little situations we have here. I'm going to look at this one right here. What do I need to do to get my x by itself? Multiply by negative 5. That's going to give us that x. And negative 5 times. Ooh, yes. I was going to say, we're going to have a negative 10 over here. I heard that. What sign's going to be in the middle here? Less than. Why did it change? Because we multiply by a negative. If you multiply or divide by a negative number, you have to change the sign. How about for the blue one? What are we going to have? This one. So we're going to have our x is greater than positive 10. Because again, we're multiplying by that negative number. Negative 2 times negative 5 gives me positive 10. And it switches my sign. So my intervals are going to be what? How do I put this in interval notation? How do I put x is less than negative 10? Yep, so we have our negative infinity to negative 10, and they both get parentheses. How about this one? I'm going to say 10 to infinity, and we join them with a u. Okay, so we did absolute values, we did inequalities, we just hadn't smushed them together. At least not as far as I recall. Questions on those guys? All right. The next one, we have done things like it. We just always get scared of them because there's too many dang on letters. It looks scary. Our goal here is to solve for x. That means we want to get this thing to be x equals. And whatever's on this side can be a hot mess for all I care. The right-hand side can be a messy, messy mess. So I want to get my x by itself. So we're aiming for that guy to be all by himself. So what do we need to make leave? Let's subtract the c first. Let's get rid of our adding and subtracting. So I'm going to minus c on both sides. So my left-hand side's not going to change all that much yet. We've got our a times our x minus b squared equals our 8 plus the square root of d minus c. Still aiming to get our x by itself. What do we need to do to get x by itself here? Divide by a. So that's going to give us our x minus b squared equals the fraction of 8 plus the square root of d minus c all over a. And the right-hand side is looking very gross, and that's okay. We still want to get that x by itself. What can I do next over here? Not square, square root both sides. So I want to square root both sides to get rid of that square. So my left-hand side, we're getting real close now. Now I'm just left with my x minus b, which equals, when I square root both sides, what do we need to put? Plus or minus. And then the rest of that hot mess express stays right there. The square root of 8 plus the square root of d minus c all over a. And we're almost there. One last step to get x by itself. Add b. We're going to plus b. Plus b. So now we have our x all by itself. And I'm going to smush the b up in front just because I like it outside of the radicals to be very, very clear. So we're going to have our b plus or minus the square root of our 8 plus the square root of D minus C over A. And it is a hot mess express, but this is our answer. X equals that. Hot mess. So it's all about following the process. It just actually lets us see your whole process in the final answer because we can't do much simplifying. In fact, we can't do any simplifying. We're not going to try and rationalize. We're not going to try and simplify radicals to deal with the power inside of power. We're not dealing with that. Leave it as a hot mess express. Okay. Questions on this one? We have one more. And then I'll be done talking at you. And it's everybody's most favoriteest. Story! Okay, that star is meant to be behind the 11. It got shifted for some reason. Switch the number to be an 11, not a 14. Otherwise, it does not work out even close to tidy. Switch it to be an 11. That should be this guy that's highlighted. It's real nasty if we don't switch it. I don't know why. And now it looks like I'm highlighting the he. There we go. So switch the 14 for an 11 in your note packet. Switch it to 11. Otherwise, it is so gross decimal-wise. All right, so we've got that Marty is buying holiday presents at a very, very steady rate. At a constant rate, you might say. On shopping day 6, he has $285.50 in his bank account. On day 11, he has $186.25 in his account. We are trying to make a prediction on how much is in his account on day 30. That means we are trying to write an equation for this so we can make a prediction. What can we do here? Say it again. Yeah. So I know that on day 6, he has $285.50. And I know that on day 11, he has $186.25. You can think of these as points, as a table, as ordered pairs, whatever way works for your brain. I'm just making that a little less common. So, what can I do from here to make some sort of equation? Find our slope. This is linear. So we want to find our slope. How do I find my slope? Yes, that is going to be our change in the y's over the change in our x's. So this is my x and this is my y. What is the change in my y's? Negative 190. Oh, yeah, I was going to say, I don't know where I got that from. I was looking at a different place. Oh, I was looking at the original piece, at the original problem. I'm like, that's not what it was. So this is that it loses, he spends $99.25. And from 6 to 11, it's a positive 5. So he spends $99.25 in 5 days. How much does he spend in 1 day? Simplify that. $19.85. Simplify. So you divide that, the negative 99.25 divided by 5. How can I make an equation with what we have here? Because I need to make a prediction for day 30. Yeah. That would tell us how much he spent in those days. But how much did he start with? You can go backwards that way. That's the kind of hard way. We worked with something fairly recently that we could use here. Remember our y minus y1 and x minus x1. Our point slope form. I've got 2 points. I've got a point and a point. We can use point slope form to write our equation. We don't have to put things in slope intercept form. You can work your way backwards to find your y-intercept. You can do a substitution where you put in your slope and your 2 points to try and find your y-intercept. There's, like I said, many pathways through, but I think honestly the easiest is to do the point slope form because you don't actually have to do a bunch of calculations on it. Because I can just take and substitute in my y minus the y value of one of my points. Dude, it said knock like you mean it. You didn't act like you meant it. And yes, I am busy. Try back tomorrow. He keeps wanting to ask me stuff for the new stuff. So our 285, that would be one of my y's. So y minus our 285.50 equals our slope, our m, negative 1985 x minus the x value from that point, which was 6. So that's a way to write the equation. And if we're trying to predict what happens on day 30, where are we going to substitute that in? Into the x. You could get the exact same answer doing it with the other point. It genuinely does not matter which one you do. I just picked this one because it was the top one on the list. So when we're trying to figure out our prediction for our y minus 285.50, negative 1985, and we're doing our 30 minus 6. Aha, fit it. Barely, but it's there. So we're just going to simplify this as much as we can. Whoa, wrong pen. Y minus 285.50. A negative 1985. 30 minus 6 gives us 24. So he has y minus 285.50 equals negative 476.40. So how much is in his bank account when he is done shopping on the 30th? Yeah, he a little bit overspent on his holiday presents. Because he has negative $190.90. He's in credit card debt. So you don't have to use the top point here. You could have absolutely done it with our pink point with the 11, and you'd get the exact same answer for our y here. You could do this in slope-intercept form, y equals mx plus b, and find your b. There's lots of ways through it. But when we have a steady rate, or if we have a constant rate, it means we're looking at a line. Okay? So that should be all the things that we need to specifically go through on the final that we hadn't talked through in a minute. We hadn't done a linear story problem in a long time. So yeah, what we have now is the last homework is that worksheet. I gave it to you guys on Friday. Technically due tomorrow. Our review packet for the final is up here under the screen. It is not Friday, it is in fact Monday. So one thing I want to point out to you guys on this beast of a packet is if you look at the very, very back, you will get this exact page in the final packet. It is this, you can't add anything to it, you cannot write on it, it's not the one that you should write on. You get this and this, okay? So, if you want to practice with why I put it in the review packet, so you can look at it, know where things are, things that it is like these formulas, like it's straight up the copy of the inside of the book cover. But that's what it is. It's better than nothing. It gives you the quadratic formula for sure. It gives you some of the special factoring stuff. It gives you log properties. Gives you exponent properties. Gives you the quadratic formula for somebody who's not super strong in that memorization. So it gives you some of the things. But in here, there are practice questions for every kind of question on the final, at least one. Usually more than one. Okay? And we have like the whole rest of this minute, like until we get to finals to work on it and ask questions and go through it. I do not yet have the answer key made for it. This is third period, so we will be on the third. Yes. And IU gives 2 hours for the final. Pike's schedule has it as 90 minutes. So what we'll do is, if you need that extra half an hour, you're just gonna hang out through fifth period, because we back right up. This is gonna be, it's 1, 3, 5 on that day. So you'll just hang out with me through the beginning of fifth period, because you will have already taken that final. You're aggressively agreeable right now. So you'll just hang out with me for that next like half hour, and I will write you a pass either to lunch or back to class if you need that time. Honestly, looking at that final, I don't know that you'll need it. I was like, the homework questions they picked were like neat, but the final were like, really? Did they send the right one? So, and they did. So I think you'll be okay. Okay? What's up? No, I made her. Oh, I haven't even reviewed part of it. What's up? I don't remember, but I can talk to you.
The only hard finals I have right now.
What's up?
Well, I was like,
Can I go to the restroom?
Yeah, please, 1 second. And Anthony, there are 18 questions on the final. 18.
Do you have different parts?
There's a couple that have ABC, but not all of them. It's not a ton. There's not all of them have ABCDs. There are a couple that do, but a majority do not.
So when it's 0, when these options.
If we get 0 equals 0, that's true forever, so that would be infinitely many, correct? Oh, I think I forgot to do, no, I did do attendance because it's on the right page. Very good.